In our next example, it says the graph shows the growth of a type of bacteria over time. It can be used to predict the growth beyond the time shown on the graph. Fill in the chart to show the approximate number of cells at the end of each time period. Well, notice we're counting by 1,000, aren't we? And then so half of 1,000 is 500. And this half of 500 would be 250. So this looks like I'm at 0. I'm kind of starting at 100, doesn't it? So 0 is 100. Looks like I double it, so I think the next one is 200. At time period 2, that's just below 500, so that's 400. Time period 3, now I'm above 500, so I'm going to say that's 800. Time period 4, we're above 1,500, so that's 1,600. And at time period 6, I'm above 3,000, so I'm going to say 3,200. And I just noticed my 6 kind of looks kind of sick there, kind of look like a 1, so I'm going to make sure that's a 6. Okay, make a conjecture about the number of cells after 6 units. Well, I think what happens is going to double again. So after 6 units of time, there would be 6,400 cells. Now, a counterexample is an example that shows conjectures that are false. So remember, we said a conjecture is a guess. It might be false. Well, here's a conjecture. It says girls don't climb trees. And if we take a look at here, here's a girl sitting in a tree. So that conjecture is false. Let's take a look at example 7. It says, based on the table showing unemployment rates for various counties in Alabama, find a counterexample for the statement, the unemployment rate is highest in counties with the most people. Well, if I take a look at that, would be Perry. Perry has a smaller population than Butler, doesn't it? But it has a higher unemployment rate. And there's your counterexample, an example that shows a statement is false. And that's all you have to do.